Why, hello, everyone. How are you on this really, really great day? And I hope you're having a great day. So, this is part two of the Wave Study Guide. Yeah, I have a paper that looks like this that I'll probably be handing out to you. I'm not crazy about, doesn't have a lot of color in it, doesn't really have a lot of great stuff. So I'm actually might not be using this paper as much as I'm going to use this one. Doesn't that look nice? Look at that. So I might go back and forth because my projector to maybe show you, remember this bad boy? To show you a little bit of this or something. But I'm probably not going to use that as much. I might refer to this. So let's start with the nice color version that you probably are not going to be given. So here we go. Okay, here we go. An earthquake is a shaking of the ground caused by the sudden movement of the Earth's crust, right? Two giant pieces of land that are rubbing against each other and they cause an earthquake. The type of waves that we are talking about this time around in part two are called seismic waves. They are different than the kind of waves we were talking about before, like sound waves, water waves, stuff like that. Seismic waves are earthquake waves. And there are three different kinds of seismic waves, three different kinds. And we can see on here we got P waves, S waves, and surface waves. Okay, so these are the order that they go in. Okay, and if I were to make a diagram of the wave as it would appear on the monitor if you were an earthquake scientist, it would go like, it would go like this, right? And so this would be the P wave, right? You can notice the amplitude is not really that big, okay? That comes first, that's the P wave. This would be the S wave, and you notice that it's a little bit larger. The S wave comes second. This is the fastest one. That's why this appears first on their machine. This is the second fastest one, the S wave. And the slowest one is the surface wave. That is the one that causes the most destruction. That is the one that causes the most problems. Why? Because these two types of waves can be found in the earth and they move in all directions like that. But this one also moves in all directions, but towards the top. That's literally why it's called a surface wave. Surface wave, right? So if your house is here, right, and the surface waves are going, yeah, that's a problem. But if this one is like, 2 miles or 3 miles underneath and it's not that bad, you might not even notice that it happened. P waves, S wave, surface waves. Okay? So let's go back to the nice colorful picture right here. P waves is the fastest. I said that. And I already said this. Moves out in all directions. I said that. Moves through all kinds of matter. So it can move through solid, through liquid and gas. It can move through the earth, through the water, and through the air. So the P wave is very special. Not only is it really fast like Superman, but it can move through all sorts of things like Superman can too. The S waves and surface waves, on the other hand, they can only move through the earth. They can only move through the ground, okay? These two bad boys. Slower, slowest, most destruction, okay? If I were to go back one more time to my handy-dandy thing here, right, or my Venn diagram, thank you, John Venn, for inventing there's one more thing I wanted to talk about with P waves and S waves and such, okay? P waves move through the earth, right, like there's compressions and then they're close together, right? Or compression is the close together. I'm sorry. It's like spread out, compressed together. Spread out. It's like a spring or a slinky that we did in class. That's how P waves move. In fact, if we look back on that diagram, your study guide in a second, you'll see that it kind of looks like that in that picture. So the P waves move like this, right? This would be the trough. That would be the crest, trough. And the S waves move like waves on a string, like right on a string, right? You know what I mean? Whatever that thing was. So waves on a string would be like this. They move up and down, up and down, up and down. I never really talked about how the surface waves move, but one of the ways they can move is like kind of in circles. But I don't want to talk about that. I mean, I don't think I even mentioned that. But whatever. I'm concerned about mentioning that for the first time here. Oh, but look, here's what the pictures show. So if you take a look, right, it shows that, see how this is like spread apart and then close together, spread. That's with the P waves. You'll notice that these go up and down like waves in a spring. And like I just said, I never mentioned this before, so you can ignore this part if you want to, but they move like in a circle. Okay, the surface waves. I never really mentioned that. Sorry about that. But that is everything I have to say about the waves of earthquakes. Okay? Digitize. Let's see. Well, if I had a book or if I had a picture and I wanted to upload it to the internet, I would be digitizing it. I would be taking something real and it would be represented instead in a digitized form. Okay? To break into sections that could be represented by letters or numbers, digitizing something. We might be doing a little art activity with digitizing. Oh, I don't want to give too much away, but we might be doing a little something, with some dots and dashes. I don't want to say too much. But that's about digitizing. That's about all I can say about that. Do you really need me to explain what a digital device is? Not really. You've got them all over the place. Tablets and smartwatches and cell phones. You don't need me to explain what a digital device is. Nuh-uh. Oh, the telegraph. Good old Samuel Morse. He changed the world. So this completes a circuit. Do you remember when Mr. Brown was doing circuits like this one? And when, this is a open circuit. That's a closed. Open, closed. Open, look at the light bulb over there. Open, closed. Well, Sam Morse does the same thing with his telegraph. This is basically like a glorified switch. And when you press it down, it closes the circuit and something buzzes on the other end miles away. So what did he do with those buzzes? Well, if it was a short buzz, that will be a dot. If it was a longer buzz, that will be a dash. And he invented the Morse code. It's a famous code. It's not a secret code, but it's a famous code. And people still talk about it today, and not a lot of people use it, but people still talk about it, and it's fun. And I've said this before, and I'll say it again. E and T are the shortest because they are used the most. E is the vowel that's used the most. T is the consonant that is used the most. Not continent. I said consonant. I used to be an ELA teacher. I know about that stuff. So that's a fun fact about that, right? And we had a lot of fun, and we'll continue to have a lot of fun with using Morse code, and we're writing our names in Morse code and all that kind of fun stuff. So that's a pretty cool thing. One more thing I wanted to show you just to kind of remind you was this bad boy right here. Remember how I said that P waves and S waves move in different ways? This is a way of demonstrating that, right? S waves are moving like the waves on a string, and P waves are moving like a coil, like a spring. Isn't that cool? It sure is, Mr. Brown. It sure is. But back to the matter at hand. Okay, so that's about that. There's not as much in waveguide number 2 as there was in waveguide number 1. There's not as many terms. There's not as many things like that to learn. But I am not going to make you memorize the Morse code. I already know that a couple of kiddos have already learned a couple of them just by being exposed to it. That's pretty cool. But I'm not going to ask you like on a quiz. Remember what the word coffee is in Morse. I'm not going to ask you to do that. That would not be fair because it's kind of a lot. There's 26 letters of the alphabet. 26. It's a lot. So there we go, my friends. That is the Waves Study Guide Part 2. I've said it before and I'll say it again. I hope you have a fantastic day. I hope if you're not having a fantastic day, that your day gets better. And I think you're all wonderful people. And I think I'm great too. So let's see you in a moment. All right? Have a good one.